Hello, ma'am.
Yeah, yeah.
Yes, ma'am. So we'll start the session. So, good afternoon, Dr. S.Bakkialakshmi, and good afternoon to the participants. We are watching this live session. And welcome everyone. Today's session feature reduction in machine learning and deep learning. In this session, we will explore the importance of feature reduction techniques and their application in the field of artificial intelligence. Feature reduction plays a crucial role in solving complex problems by simplifying the presentation of data. It aims to identify and select the most relevant and informative features from a given dataset while minimizing the loss of information. By reducing the number of features, we can overcome challenges such as dimensional data, noisy or irrelevant attributes, and improve the overall performance and efficiency of machine learning and deep learning models. Throughout the session, we will examine real world examples and case studies to highlight the practical applications of feature reduction techniques. We will also discuss the advantage and limitations and best practices for implementing these methods effectively. Before we start Dr. V.S. Bakkialakshmi session, I would like to give some introduction about her. We are delighted to have Dr. V.S. Bakkialakshmi as our esteemed guest speaker for today's session. Dr. Bakkialakshmi is an assistant professor at SRM University, bringing with her a wealth of knowledge and experience in the field of computer science and machine learning. Dr. Bakkialakshmi holds a PhD in computer science engineering, which she recently completed in February 2023 from Hindustan University in Padur, India. Her doctoral research focused on a specific area of computer science, which makes her an expert in her field. Her passion for advancing knowledge and understanding in her domain is evident through her pursuit of higher education. Prior to her PhD, Dr. Bhagyalakshmi earned her Master of Engineering in Computer Science Engineering from Anna University, India in June 2007. She also holds a Master of Philosophy degree in Computer Science from Bharatidasan University, Tiruchi, India, which she completed in August 2005. Additionally, she obtained a Master of Science degree in Computer Science from the University of Madras, Chennai, India in April 2002. Her dedication to expanding her academic credentials showcases her commitment to learning and staying at the forefront of her field. At the end, I would like to introduce to the motto of Dr. V.S. Bakilakshmi: simplify, enhance, optimize, analyzing the power of data. I would like to hand over the session to Dr. V.S. Bakilakshmi, and also thanks a lot for joining us today, and over to you, ma'am.
Yeah, thank you so much, dear, for this nice introduction about myself. And I would like to say my good afternoon to everyone who are watching this particular live program. And here I'm, yes, as introduced, as I'm Baki Lakshmi. My research area is machine learning and deep learning and affective computing. My domain is affective computing. So here I would like to take my session on feature reduction alone. Okay, so let us get into this session where our today's session as an agenda will be feature reduction, why called dimensionality reduction. So you might have heard about this term everywhere, FR and DR, why it is so. So, why dimensionality reduction is required? That is the major concern. And next is what is curse dimensionality reduction? What is the curse of dimensionality reduction? And the process of dimensionality reduction. So, as I discussed here in this agenda, so we will be looking only all these these particular topics where we are going to get involved into and start with feature reduction. So starting with feature reduction, whoever working in machine learning or deep learning, definitely you will be evolving with a set of a huge number of data sets, so where definitely feature reduction will be involved in your process, right? So before that, what is feature reduction, why it is also called as dimensionality reduction? So normally the basic understanding of feature reduction, people used to understand that is only dealing about the features making it is to reduce to some amount of thing and working it out. It actually not works like that. Feature reduction is this is not making a huge number of data set into a small number of data set. This is actually the features are in multiple dimensions of features will be one dimension, two dimension, three dimension, or something more than that, multi-dimensional one. So where that dimension kind of features will be reduced to a single or two dimensional feature things which were applicable for your research area. Okay, so basically what is features? So everyone knows about it, that is input variables are called as features, right? So whatever the values you are going to input into your that is the data set, from the data set, each and every features whichever you are going to use, that is it, your input variables are said to be a features. So what is feature reduction? Okay, so it is a process of reducing the number of features. So if you have 1000, you want to reduce into some 500 or 300, 200 count and make it as an effective data feature count and getting for the computation. That is what we say, reducing the number of features in a resource of heavy computation. So we are doing some heavy computation, but which are the major line to be underlined here is like without losing any important information. Okay, so here feature reduction, where we will be completely taking care of our features, where the unwanted segments to be removed from it, and the important data whichever we needed, it should not be lost. Like we can say, that is the noise which is created can be removed, where the irrelevant values whichever it is came inside, it should be removed. So reducing the unwanted things and making the data set very perfect, crucial one for our work. Okay, so FR to DR. What is FR? Feature reduction. DR, dimensionality reduction. So in my right side of the page you can see a diagram. That is, let me take a marker. Okay, let it be. Fine. So here you can see a picture where you can see this is a dimensions of the feature space it is being occupied here, and also here down share you can see a multi-dimensional data where how it is being taken. So here you can see the data are being set up in the features have been set up inside a multi-dimensional array, where you can see some feature space is also allotted for it. So wherever it is needed, it should be allotted. So let us discuss more deeply about this. So before that, let us understand feature reduction to dimensionality reduction. So let's consider the columns of the data representing the dimensions on an n-dimensional feature space, and the rows of the data points are the spaces. So in this diagram, you can understand it very clearly. The columns of the data representing the dimensions are the n-dimensional feature space, and the rows, okay, the rows of the data points in that space is the space that is said to be the feature space. So this reduces the number of dimension of the feature space, hence the name is dimensionality reduction. So when your feature spaces are reduced, the dimensions of the feature spaces are reduced, so that's the reason. So the dimensions is being reduced, the dimensionality reduction is reduced, that is from 3 dimension it is reduced to 2, or 3 dimension it is reduced to 1, then it is said to be the dimensionality reduction. Okay, so coming to and just getting little bit deep under the dimensionality reduction. So dimension reduction is one of the process of preparation of a data, right? So you're going to prepare a data. So whatever data you're going to collect it, or you're going to get it from any data set sites or wherever it is. So the data whichever you are collected, it should be have some preparation, it will be having some process for the preparation, right? So what is that process? So everyone knows about this. What is first is data cleaning. Okay, what is data cleaning? Data cleaning is you're going to take it. So either your values can be in you will be expecting your values only in zeros and ones. If you're finding any other numbers, then it is a data cleaning, and you may find that there's booleans or something like that. Or you can take like this: if you are having some values which is to be in numbers, and you may be seeing some alphabets, characters, something special characters, then that should be removed. So another method of data cleaning, what are the unwanted data to be cleaned here? You can have, you might be expecting only decimal number of you might be expecting only the numbers. There you can find some decimal number of waves, like in the waveforms or signals you might find these problems. So those are the data to be cleaned. And transforming the data, so you can see if in this kind of things you can, and I can give you an example, like it may be not be a whole number, you can be converting into a whole number or something. So then the data transformation is happening, and the feature engineering is happening. Here you will be implementing your own techniques, the particular engineering works. Like if suppose take a, it is a medical related data set, then you have to engineer these features, right? You have to take some proper filterization. You will be having different multi dimensional of image processing data set. So you will be having some set of engineering works to be done to it. So that is the third one. And reducing the dimensional reduction, so the dimension reduction is the end point of your any kind of work. You need to it need to be done at the for getting a proper exact result for you. So here the dimensional reduction, it is going to happen in either it will be in a three dimension. Let it take a medical dimension image itself. So there you can see the images will be in you need to calculate this particular image in a multiple dimension only. But when you are putting it in machine learning or deep learning algorithms, this will not support you to get an exact result, like exact statistical result measures, you will not be able to gain it. So in the diagram you can see that your three dimension has some thousand propositions, where it will be in the two dimensions maybe have a hundred proposed positions to be placed your data. And next in the one dimension one, you will be having only 10 positions to make your data very clear. But will it work every time that multiple multi-dimensional data set one will be to be reduced to the dimensional? When the dimension reduction will be done, only the value you will be able to use your data set? No, it's not like that. In many of the cases, mostly in the medical data set, definitely you have to take care of your data set in multi-dimensional, reduce it, make it into a statistical measure, put it into your algorithm. Then again you have to make it up in a multidimensional picturization for getting up the proper result. So have using your data set in multidimensional, it is not at all a mistake. But to get a proper understanding, because our machine learning and deep learning algorithms and the concepts whichever we are using in our current scenario, this is matured that enough, we have to reduce it and make the result comfortable to be as with the proper statistical measures. Then the performance will be good, your algorithm performance will be good. So DR refers to the techniques that reduces the number of input variables in the data set. So you're reducing the input variables and making it very sharp to get your perfect result to be the answer. The large number of input features cause poor performance of machine learning algorithms. So where the DR study concerned with reducing the number of features, one, and high dimensional spaces. So you can see this diagram itself. It takes the high dimensional spaces where it need to be the dimensional reduction transforms the data into the low dimensional space. So the low dimensional representation retains the meaningful properties of the original data. When you are reducing the high dimensional space to a low dimensional space, then too you have to get retained with your proper original data meaningful values, right? So that will be happening in dimensional reduction. Reducing the number of features is not the deal, but reducing the number of features with the proper meaningful properties from the original data, whichever you needed to be evaluated, that should be there. So it should be having the intrinsic value, that is belonging to things which is very true. What you want, it should be there. When reducing, it should not move out from your focus point, right? So why is dimensional reduction is required? So here you can see this diagram where the high dimensionality reduction is low to low dimension. How the processes happens. The space required to store the data is reduced as the number of dimension comes down. Okay. So either it can be a one, two, three dimension, four dimension, five, whatever dimension of values you are occurring. So it should be reduced to a lower end. In the maximum, they will pull out to the single dimension way or two dimension one, because image processing normally it takes two dimension minimum, and some other data oriented where only number value oriented data set, then we can make it at to a one dimensional one. And next is less dimension lead to less computation and training time. So this is very important, right? Whatever research is going on, at last an end of point, the single line question is how much you say accuracy, how much time it is in how much time you have received this particular accuracy, how much efficiency it is giving in shorter number of time. So the computation time is very important. This is the major reason we are jumping into this feature reduction, that is making your dimension reduction to make your lead to have a less computation and training time. Okay, and the next point is some algorithms do not perform well when you have a large dimension. This is the proper thing what I was discussed in the last slide also, that is machine learning, deep learning algorithms, whichever we are into right now, we are running into, it is not that much matured, where you can just like that pull your data and just like that get it out with your answers. So yes, we will be growing up as the same we have grown so far, but even now, that's the reason so much, so some algorithms may not, will not perform to the large dimension of data sets. So that's the reason. And next is visualizing data becomes better when reduced to 2D to 3D and 2D and 3D. So visualizing data becomes better when reduced to 2D and 3D. Plotting and observing patterns becomes more clear. If it is a much dimensional one, it is having a cubical value of so much of things, and you will not be able to point the patterns and find it and observe the thing, observe the answer properly. Like you will not get the perfect result, like the accuracy may be falling down. If you get the accuracy in higher dimensions, then you are going to implement in a smaller version of project, then definitely it is going to be a problem. So visualizing the data becomes better. The reason is for plotting and seeing how the patterns forms, and that is the major, another major reason, and removes the redundant features. So at last, for all these things, majorly we remove the redundant features which is not at all required. Okay, so what is one of the major cleaning process? And next is from our agenda, let us jump into this curse of dimensionality. So, what is the curse of dimensionality? So, here from your in this diagram, you can see we have shared some 1D, 2D, and 3D regions. So, you can see a wind mill, wind power in a mill here. Into that is it just we are trying where I'm trying to show you pictures. Windmill is the same location, same windmill. It is, the picture has been clicked from different angles. That is the single difference between these two pictures. So that is that is the main difference we would like to show you here. That is one dimensional, two dimensional, the same thing, the same content, the same value will be there existing in the same location. But when you are in nature, naturally from your eyes itself, when you see and feel it, you will see different thing. Here you will be seeing five wings, but this is not five wings solar wind power, right? And it is gathered with another one which is standing behind. So when it is seen in multidimensional, yes, you can have a very clear vision of understanding. But taking it as a one single answer to be find whether it is a windmill having a proper fans or not, yes, one dimensional gives the result. So there is a different, there is a too much, there is a massive difference with getting the results from single dimension to the multiple dimension of vision. So it can be having four regions one, and this will be a 16 region one, that is two dimension, where you will be plotting in 16 region. But when you're going for the 3D dimension, it may be crossing 64 regions also. Yes, three dimensions, 64 regions, you are plotting in 64 areas, so you will be having a better pattern, and you'll be understanding it. But when it is coming to the exact curious answer, then jumping into the 2D or one dimensional region. So where the curse happens here. So analyzing and organizing data in high dimensional spaces, that do not occur in low dimension settings, right? Such as three dimensional physical space. This is the curse we see in the dimensionality reduction. And next is cursed phenomena occur in domains such as numerical analysis, samplings, combinatorics, machine learning, data mining, databases, where we will be having this problem of multiple dimension data set usage. And next is when dimensionality increases, the volume of the space increases so fast that is available data become sparse, right? So the available data will be spread out all over here and there, and sometime your data, you will maybe finding some problem in taking care of all the data whichever you are needed in very important manner. So that time you will be need of taking care of your data set in a low dimension value. And the sparsity problematic for any method that requires statistical significance. So that is the major concern we have to see over here, that is the sparsity is a problematic one for any method we are following here. So when it is sparse, that is it is spreaded out, sprinkled like somewhere here and there, then definitely that is going to be a problem for us. Next, the process of dimensionality reduction. This is the what we have seen. What is dimensional reduction? What is feature reduction? For a feature reduction is considered as a dimensional. DFR is nothing but DR. That there is nothing, no confusion in it. And so for this particular process, feature reduction, dimensionality reduction process, we will be having two different process. The thing is, for specific domain, specific problem solution, we will be jumping onto these two things. For specific problem, we will be handling both selection as well as extraction in the same problem. Okay, so it is not like that you will be using only selection and going on with this particular process, and extraction you will be taking care of this particular applications and run like that. It's not like that. Yeah, you can have, you for feature reduction you will be going into selection, extraction, and then the reduction process, the set of things will be accumulated. Okay, so what is feature selection? So it will select a subset from the original data set. It will select a subset from the proper original data set and moves on. So for what kind of applications? Applicable for micro array data and text mining, weather forecasting, image processing, etc. For this kind, the image process, that's what I said, selection extraction comes in both the work. So selection can also come in image processing also has the feature extraction also. So majorly we can see the difference in weather forecasting normally it stands like it will be standing in the historical data and gives the current one, like current weather will be not, we are not got to detect the weather of the current scenario, right? So whatever weather we are calculating, we will be calculating with from 100 years of data set. So that weather forecasting will be happening with proper selection, like in the July month what will be happening in the June month, in the date of 29th, in the time of 3 o'clock, what has happened for the past 100 years, it will be evaluated and the pattern will be followed and the result will be given as the today's weather. Okay, so this is what the weather forecasting. So there we can be fixed up with the subset, like we will be fixing up with the selected subset of the original set. Where it is coming to feature extraction, you have to generate a new feature from the existing set. So they will be creating a new feature from the existing set. What is new feature from existing set? The like use the applications which are using ECG signals, wavelet domains, and image data and etc. So image data here for feature extraction, we will can consider that as a medical imaging data set. And the wavelet kind is what? EEG, ECG, GCR, or EDA, whatever kind of wavelets, wave kind of feature data sets comes. There you will be taking the combination and making a new features from the existing one, and making it as a perfect feature for your final algorithmic implementation or whatever it is. So there is some difference, like what is selection and what is extraction. Okay, so feature selection and the strategies, why it is happening and what is the selection procedures, why, what are the strategies to be followed. So it is used, the feature selection, it is used to simplify the models to make them easier. Okay, once you select the features, as we discussed for some past slides and everything, we are having a for simplifying the models to make them easier. Why? So you will not be able to take 100 plus and 1000 plus and 10,000 plus data for putting into an algorithmic form, that is putting into a model. Okay, So for that, to making it simplify, we are doing feature selection. And the shorter training time, when your features count is less, yes, your training time will be shorter one. So enhance generalization by reducing overfitting. So it should not be an overfitting process, right? It should be enhanced by reducing the overfitting process. Whatever you are giving, it should fix into your model, and the model should work perfectly. The answer should come out. So it should not be an overfitting one. So make it as a by reducing the overfitting process. For feature selection, we have three different methods. So any of the feature selection, it will be we can put it in all any of these three methods. Okay, the first one is filter method, wrapper method, and embedded method. So what is these three different methods, how it is being done? So here we are not going to get into very deep inside this feature selection model, the methods we follow here. If they are going inside, then definitely we have to take a real case scenario and we have to work towards it, which is a very long process. Let us understand what is filter method. Filter method is nothing. Yes, we will be having set of features and all the stuff. We the feature selection is in filter method. It is going to happen according to the ranking. We the topmost features whichever it is used. Say if it is an ICT project, okay, you are going to handle agriculture, uh, some agriculture related data set. Say what are the major features that will be involved inside that. So if suppose we are going to plan a plantation, you are going to plan a plantation, let us say talk about some herbal plants plantation to be done in that soil. So automatically you will check into the weather first, weather and the soil condition, and what kind of landscape it is, and what kind of water supply you will be getting for that particular plantation. So when you are talking about basic consideration itself, you are taking care of these four things, right? What land it is, what kind of what amount of water you supply you will get it, and what kind of weather condition your the location is having. So these are the major things leading. So the ranking will be positioned like this. What are the features? You might have 100 features for this particular plantation of a herbal plant. Then definitely the majorly you will be having some set of features to be selected. Okay, so you will be giving a ranking one. So water is important, the landscape is important, those features will be gathered together, the ranking is given, and that according to the ranking, first 10 ranking or first 50 ranking of features will be taken, and the topmost ones will be pushed in for the evaluation. Okay, so this kind of filter method is said to be the in the selection method. This is the filter method. Wrapper method is normally where we used to work for our repetition kind of things. Okay, so you'll be having a set of data set, you're having a data set where the potential data set is there. You will take those potential data sets, take it separately, evaluate it, put create how you're going to do that evaluation. You will be doing this evaluation with models. Okay, you will create some model, that is your model which will be you will be having for the training one. You create the training one, once it is work out, you will jump into the testing model. But for evaluation you put a model, calibration done. If it works out, yes, repetition is done, again the model will be evaluating for until the optimal result comes out. So this is said to be the wrapper method. Next is embedded method, where the embedded method definitely you will be having a exact model. You will take it, put your all your data sets, work it out, unwanted removed, that's it. So here the feature selection has three different models, that is filter, wrapper, embedded. Any kind of projects whichever we are involved, definitely it will be having the three method will be used in the feature selection. For filter method, we can give an example like image, not image processing, you can say this EEG kind of wavelet kind of transformation, that those kind of methods can be used in the filter method. Wrapper method, if you have the iteration, continuous iteration is going to run and run and run and again and get the final value, then wrapper method. Embedded model, yeah, you will be having a proper application, put it inside, work it out. So the key points for selection of this particular feature selection is the subset selection. That is very important. It starts with the empty data set. There is a data set. When the subset is collected, yes, it will be empty. It starts with the empty data set, collect your subsets. So try each and every remaining features. It will you when you are getting out your subset selection, you should not be under your priority selection. It should be under the priority selection of the domain you are working to, the work, the project, basic application which you are working towards, the result. You should have to work according to the result, right? So where you should not leave any kind of any features there. Each and every features has to be checked whether it is needed or not. Okay, that is what the filter method, evap method, everything does that. Every method checks care of its each and every features. So estimating through the classification or regression errors for adding each and every feature. So select features that give maximum improvement. So you have to the priority features whichever it is taken care, that should have the proper maximum improvement should be done. So stop when there is no significant improvement. Don't waste time, because time consuming the time for any process, it's going to give you the effective result at the last, right? So you have to take care. If there is no significant improvement, definitely stop at the moment and go ahead. And next is feature extraction, where an initial set of raw data is used to more manageable groups of processing. So initially what is happening, the raw data is introduced to more manageable groups for processing. For so far we were seeing the selection process, how it happens. Now the extraction process, how it happens. The first key point for extraction is the feature extraction aims to reduce the number of features in the data set. So the major aim for reduction itself is reduce the number of features in the data set. But how? By creating a new feature from the existing one. There are existing one, selecting and working out is selection. Extraction is what? They are features. You have your end of process is what? You have to reduce it and form work toward. But creating a new feature from the existing ones and then discarding the original features, okay, without disturbing your originality. So that is the major key point in feature extraction. The second key point is feature extraction, also called as feature projection. So this transforms the data from high dimensional space to the fewer dimension spaces. We are not saying low dimension, fewer dimension. Okay, feature extraction is called as feature projection. So the projection of the features can be from multidimensional, high dimensional, multidimensional, high dimensional, everything is same. But why we are mentioning as high dimensional extraction is you may cross some more number of high dimensional values where it stands in all the feature spaces. You will be reducing it into the fewer dimensions to get the proper extraction, because our main key point, the one key point one says what, it takes a new features, it creates a new feature from the existing one. So from the high dimension, when you're coming to the fewer dimension, definitely the space is reduced, where you will be creating a new space, new dimensional values for the new dimension feature values, and you will be working together. So that is the second key point. And the third key point is feature extraction can also reduce the amount of redundant data for given analysis. So if there is any redundant data at any point of any, and after any cleaning, after any reduction happen, yes, the extraction process perfectly works. That is to reduce the redundant values. Redundant values, first major problem when redundant values are existing in the process is it is going to waste our time. So for this consuming for the result, it is very important taking care redundant data. And next is feature extraction can be linear or non-linear. Linear, non-linear, definitely we know the meaning of what is linear and non-linear. And when the data set has the same flow, the neutral flow in a single straight line, definitely feature extraction will, the linear, non-linear, you can have it in all the supervised or unsupervised thing. But when linear feature extraction is taken, it will be a unsupervised one. Okay, so linear data feature extraction, supervised data can be go forwarded. So linear data as well as non-linear data, I have given some sample works where it is happening is PCA, LDA, PCC and SVD. So here this particular linear feature extraction process can be combined with some other model and combined with some other extraction process, and we can create a hybrid combination and make the process very efficient. Okay, and next is this one is non-linear one. Manifold linear algorithms can be used here, and multidimensional multilinear subspace learnings also can be proceed forward. So we are stopping with this. This features can be in the one stage, in another one in a single series, and features that are not arranged traveled in the straight line. So here we will be we can go much further into this linear feature extraction concepts and go on, but that every topic is a huge one. So just with the knowledge we are stopping here. And next is when linear dimensionality reduction. So so far we saw linear feature extraction, how it happens and all the stuff, the models and all the stuff. Linear dimensionality reduction, how this looks like. So when the linear dimensionality reduction happens, the process goes on, you will find the answer in this form. So you will have this multidimensional viewpoint to a single or two-dimensional viewpoint, where the values will be very clear, where you can find the pattern of the data flow and find the answer in the very proper way. So when this solution is formed, when the linear dimension reduction is happened, in the linear dimensional reduction is happened, and the work the data flow is formed, automatically your model, whichever your algorithm we are creating with this, any kind of process model flows with any algorithm, definitely you're going to get maximum accuracy with that. So following the dimensionality reduction according to the data set whichever we are using, it's going to be a beneficial one for us to the answers, whatever the results we are planning to get on. So yes, with this we are closing with the title feature reduction and coming to an end of my session. So if there is any queries, please.
Yes, ma'am. Some questions here. So, what are the most effective feature reduction techniques for handling high dimensional data in deep learning models?
Come again.
What are the most effective feature reduction techniques for handling high dimensional data in deep learning models?
See, deep learning, the question itself, you are saying deep learning models. So, feature extraction technique is also falls on different types actually. So here that's what I have given some some methods. So here, if suppose you are for jumping into some image processing, and for yeah, I can talk about for filter method, we can go on and talk about EEG method. Then we can say Park McClellan method and stop band method, and all these methods comes under filter method. When you are going to image processing, it's completely different. So you will be running behind the eigenvalues and eigenvectors. PCA models will be running out with that. So there you can jump into kernel hybrid method and all those stuff. So this we cannot put say that this particular model or method will be work perfect for the feature selection, feature extraction. It's not like that. According to the domain and the application which we are working towards, it depends upon.
Okay, thank you, ma'am. And how can we combine feature reduction techniques with the transfer learning to improve the performance of deep neural networks?
Yeah, neural deep learning, when you are coming neural networks, artificial intelligence, and next coming into the neural networks. And neural networks itself, when you start the neural networks concepts, it's completely artificial intelligence. Neural network is, you can say that you're going your whatever the your brain is thinking, it should be happened as an application, right? So for that, neural network works. So this neural network process can be used for any kind of brain transformations. That is, wherever EEG kind of data set is evolved, then there the neural network process is going to happen, right? So their emotions, psychologies, psychological understandings, where you are working into psychological data, where you are analyzing a person's personality, his emotions, psychological turnovers, or is mood swings, or you can talk about an autism kind of disorders, or child ADHD kind of disorders. Definitely this particular emotion based data sets will be used. So there, when you are coming to EEG kind of data set, yes, your question answers here for high dimensional emotion related data values. So there the feature reduction will be working down for handling the minute transformations. See, if suppose when when a person is evaluated, taken care of, uh, deriving his EEG data set from his brain, okay, even your head check will give so many noises inside your data set. So that particular kind of application, when you are working, yes, your feature reduction, dimensionality reduction to be implemented, that is the major massive work to be done here. So yes, I hope I answered.
Yeah, okay, thank you, ma'am. And what are the challenges and strategies for feature reduction in the context of streaming or dynamic data?
Yes, they, you will be having this problem in static and dynamic data. That is what I gave this example. The previous questions example also I have given you. When you are taking a brain data, right, that is from EEG, so you will not able to sit like a robot. You are not a static person. A human is not a static product, right? So your dynamic one, even your head shake, your mood swings, or your eyeball shake, everything will be calculated. So when it is a dynamic kind of data reading or data extraction or data analysis in a dynamic way, yes, feature extraction and reduction and selection, these all things to be involved, it will be majorly involved for making it happen very shortest way. So here, for that particular kind of research things, filter method goes on very well.
Yeah, okay, ma'am. And are there any emerging feature reduction methods specifically designed for handling unstructured data types such as text or images?
Yeah, for this wrapper method will go on for feature selection and deduction. So for NLP kind of project works, so for NLP kind of project works, whichever it is happening, like you can say the social media related um, projects. See, even a chatbot which you are working in Amazon window, or any other major window, like your shopping windows, you are responding to a chat bot, not to a perfect agent. When you are in very emergency need only, you'll be getting into the chat bot. So here this directions to be needed. So you, whatever you will type from your mind will not be the exact terms whichever it is given to the bot. So automatically the bot will work towards this repetition. It will put into the model, it will calibrate, repeat it, it will get the optimal result for its question. The question, it needs to be answered. So there, yeah, the question whichever you asked, it works here. So
Yeah,
NLP
okay.
model, NLP modeling will be the answer. Yes.
Okay, okay. Thank you, ma'am. And how can feature reduction techniques be adapted for time series data analysis in machine learning and deep learning?
Come again.
How can feature reduction techniques be adapted for time series data analysis in machine learning and deep learning?
Yeah, time series. Yeah, like, as we discussed so far, we are discussing only about the time consummation of the process only. So entire our session was explaining that same.
Okay, and thank you, ma'am. Last one. How can unsupervised feature reduction techniques such as autoencoders or generative adversarial networks be effectively applied to semi-supervised or weakly supervised learning scenarios?
Once again, unsupervised.
Unsupervised feature reduction techniques such as autoencoders or generative adversarial networks be effectively applied to semi-supervised or weakly supervised learning scenarios?
See, semi-supervised itself, we are trying to make that process to be supervised, and the results will be taken there. Linear and non-linear process can work in the process of unsupervised learning. That's what we were explaining here, like how it can be further followed with feature extraction in an unsupervised way. It can be both with linear and non-linear one. So either if your data set is going to be in a linear way or in the non-linear way, either it is going to be a static or non-static, feature extraction in the unsupervised method, definitely it will work towards. So this auto encoders and all this stuff with all the, if it is a text based one, definitely your NLP models will work very good over here. So if we are going to talk we have to explain more about that, then we have to big session should be open for it. So that may be the simple answer for the question.
Yeah, okay, okay. And what are the limitations and potential biases associated with the feature reduction techniques, and how can we mitigate them?
How can we
Mitigate them.
mitigate?
Yeah, yeah.
Yeah, mitigate. Your question again.
And what are the limitations and potential biases associated with feature reduction techniques, and how can we mitigate them?
See, up to my point and my research variations, I cannot say that I can biases. Like I don't have any biased things and all the stuff. But for this future reduction, when you are working with a big data set, even though if it is going to cross some 5,000 numbers or 10,000 numbers of data set, definitely you have to jump into this machine learning deep learning concepts. When it is crossing more than thousands of things, definitely you have to work with the deep learning algorithmic structures only. So we cannot say that is it can be biased only with the machine learning or only with the deep learning and all this, nothing like that. But as of the societal culture, and we are our maturity of an algorithm, we have crossed the machine learning kind of data implementation of data set, where if suppose in many medical imaging kind in brain nerves and all the stuff, we were not able to cross the machine learning algorithmic limitations. So there we are biased with machine learning. So in some of the medical imagings, like for a gynecologist kind of endometriosis and all the stuff thing, we have to jump into deep learning because it is very minute. So we cannot say that we are biased to it. The limitations is here only. In this only we can struck out. Yes, in medical field itself we have two different things to be analyzed. If it is a brain, we can be in many process of brain things, we will be stuck down with only with machine learning concepts. If you jump into deep learning, then again it will be some problems and accuracy measures will be the maturity is less. But when it is coming to some gastroenterical kind of medical data set, then we cannot stuck with machine learning. That is more matured. We can have to go to deep learning. So limitations and biased, I can explain in these two methods. That's it.
Okay, ma'am. And this is my final question. Are there any novel feature reduction algorithms or frameworks being developed that leverage concepts from reinforcement learning or evolutionary computation?
See, this is also a generalized question, and every question I have feeling that is a generalized question. So this question is also particular for each and every concept whichever we are working towards. Okay, so for each and everything, the algorithms are more mature. The combinations of algorithms are there. The hybrid algorithms are there. The effective answers are there. So researchers, like tons of researchers are done in this particular field for reinforcement and everything. So I cannot keep point and say that this particular three algorithms are good and all this. It's not possible also.
Okay, ma'am. Thank you, ma'am.
Yeah.
I think for questions are over here. So the answers are very useful. I hope the access and that the participants can understand about that. So finally, ma'am, ladies and gentlemen, I would like to express my sincere gratitude to Dr. V.S. Bakkialakshmi for her invaluable contribution as our guest speaker in today's session on feature reduction. So Dr. Bakilakshmi's extensive knowledge and expertise and insights shared during the session have truly enriched our understanding of feature reduction techniques in the realm of machine learning and deep learning. The depth of experience and research accomplishments have shed that light on the practical applications and challenges of feature reduction and leaving a lasting impact on all of us. We would like to extend our heartfelt appreciation to Dr. Baki Lakshmi for taking the time to share her expertise and enlighten us with her invaluable perspectives. Her dedication to advancing knowledge in the field of computer science and her commitment to education are truly commendable. So, lastly, we express our gratitude to all the participants for their active engagement and enthusiasm throughout the session. So your presence and eagerness to learn how made this even meaningful and rewarding. Once again, we extend our heartfelt thanks to Dr. V.S. Bakilakshmi for her enlightening session and wish her continued success in your academic pursuits and future endeavors. So thank you all for being a part of this remarkable session. And thank you, ma'am. Thank you so much for your time. And thanks for your amazing session. Thank you, ma'am.
Yeah, thank you, Tense Tech Solutions, and all the participants who were joined the session. Thank you.